Hello, and welcome to the second screencast in the series regarding Ethereum on the Raspberry Pi. Today's topic is smart contracts. Quick review. A smart contract is a chunk of code that exists on the Ethereum blockchain. The code is replicated by all the computers on the network, and the computers use the blockchain to synchronize and to exchange money. Today I'll show you how to run smart contracts from your Raspberry Pi. I'm going to do this in 3 steps. First, I'm going to review the environment as we set it up in our last video. I'm going to explain what we have and why we have it. Then I'm going to review a smart contract that I recently deployed. It's an automated vehicle registry service, as one might find at a DMV or MOT, what have you. And third, I'm going to show how to call that contract from the Raspberry Pi 3 terminal prompt. Okay, let's begin. Environment. First, why the Pi? Well, it's the smallest, cheapest computing platform that gives me full control over my environment. I install the operating system, I control the backups, I have full privacy and security over this environment. Let's check the version. The Pi runs a version of Linux called Raspbian, specifically for the Raspberry Pi. That's great. Now on top of that we've got Google's Go language. And on top of that, we've got something called Geth, which is a very popular tool around the world for interfacing with Ethereum. And I can check the version of those things with there. I've got Go version 173, and I've got Geth version 167. Now I'm going to do all this from typing in commands today, but in order to prevent mistakes and be more efficient, of course, you want to script all these things up. And to do that, you can run JavaScript. And we've got this command node.js that we have installed. And Node's version is to run JavaScript. Now, to connect Node and Geth, we need this other thing called Web3. So there's a command up here to install that. And we've already done that. And that's our environment. Next we're going to get into the vehicle registry and show you how to interact with it. To look at the smart contract, let's head over to the Ethereum blockchain and see how it's deployed. Now, in order to talk to a smart contract, the first thing you need is its address, and that address has to be listed somehow. So in the case of our vehicle registry, let's say our DMV has put up a smart contract address on their website. And I have copied that address. This is, and I'm going to head over to etherscan.io, which is the blockchain explorer. Now this is the main public Ethereum blockchain. I've done my smart contract on a testnet called Rinkeby, so I'm going to head over there. And I'm going to take that big number that I copied and I'm going to paste it in the top right corner here. You can see that this is the Rinkeby testnet. Alright, and here's our smart contract web page. Then we click on contract source. And what we are interested in here is human readable source. But what we're more interested in is this thing called the Abstract Binary Interface, or ABI. We're going to need to import this back into our Raspberry Pi environment in order to be able to call the functions that you see above. Let's go back up to these functions. Here's the bunch of code, but here's the business logic. You've got a function register to register a vehicle, transfer to transfer a vehicle from the caller to a recipient's address, and then you've got a function to dispose of the vehicle once it's written off. And there's not a whole lot of code here. It's only 50 lines or whatever, but it implements the basic function of a registry. So let's go back and grab this contract ABI, the whole thing, and copy that. Okay, I've copied the source code, or I should say I've copied the ABI, and I've come back over to the Raspberry Pi terminal here, and I'm just going to run my connection to the network is Geth. Remember, the name of the network is Rinkeby. I'm going to enable the RPC interface and run in light mode. That'll take a second. And we'll let that warm up, and then I'll come over to run geth attach, and since I'm on Rinkeby, I have to provide this extra argument, but I wouldn't have to do this if I was just connecting into the main Ethereum network. So this gives me a command line. Here you can see I'm in Geth, and this is the JavaScript speaking command line interface. So first thing I'm going to do is define this variable of the ABI that I just copied from the smart contract on the blockchain. Now this is not usable directly. I'm going to have to convert this to an object. I'm going to call it ABI, and it's JavaScript object notation parse. This text is in JavaScript object notation. I'm going to convert it from text back to an object. Okay, there's ABI. Remember, there was a fee. Now, rather than the fee has to be specified in Way, which is the lowest possible unit in Ethereum, but it's so hard typing a bunch of zeros that it's better to just go for Finny, if you remember that from the source codes. Oops. Web3 to Way. There we go. And we can show we've got that by going console.log. There it is, for Finny in Way. Now let's take a look at my vehicle. And my VIN happens to be, I just copied it down and wrote it. Alright, there's the VIN for my Honda. And we've got some variables defined, but oh yeah, SCA. The address of the smart contract that we're going to call is this big ugly number that I had before. Okay, so this doesn't tell us anything about actually how to call it, so I'm going to create another object, vehicle registry object, and this is going to be the client side of the smart contract. So I'm going to go eth contract ABI. ABI is that object that we created from the text that we copied from the smart contract. That's the template, how to call the functions, and then we give it the address. And now we're actually ready to talk to this thing. So there are two kinds of calls you can make. One changes the state of the blockchain and one doesn't. So the one that doesn't change the state of the blockchain doesn't actually cost you any money to call. So let's take a look at what the fee is. Remember, that didn't change anything. That was a constant function. Alright, now the contract on the blockchain just answered that that's the fee. Let's take a look at the agency. And that's the address that created the contract, and that just happens to match my account here that I'm using for testing. Same address. So I created the contract from this address. Now let's actually cause something that changes the state of the blockchain. Let's register a vehicle. So now let's go register the vehicle, and let's say my VIN. I have to provide the VIN. Now we have another object that we have to provide, and that's this is what you have to provide in any Ethereum call. You have to tell it which account is going to be funding this call, because remember, this call costs money. Okay, that's going to come from my account. Now we have to pay the fee. That's what the object demands. It won't do anything unless we include enough fee. And then we also have to provide gas. Gas is the number of units it's going to take for the contract to do its work. And each gas is worth a certain amount of money, not much. So in this case, I'm going to say I'm going to send 50,000 gas, which is probably more than enough, but that is going to convert into, less than a buck worth of test coin, not real coin. And it's going to come back. Oh, yeah, it didn't work because Geth has this built-in feature that it prevents you from spending money by accident. So you have to actually unlock an account before you can spend. And my passphrase. It's going to take a second to decrypt my private key, which it needs to sign the transaction. In a second, that's going to come back and say true. And then we'll be able to actually repeat this register command. There it is. And back comes the transaction hash. And in order to validate that I've actually registered my vehicle, I can come back to Etherscan, and you can see I still got the same page. Click on transactions, and we'll just reload. And there's the transaction that I just sent. That hash is what was returned from the command prompt. So you can see there's a lot of typing that was done in order to make this happen. It's very error prone. It's much better to script up these commands into a JavaScript file, which you can run separately through Node, or you can source through the Geth command prompt. But that's basically it. There's no buttons, no fancy widgets, nothing in the way. That's just calling a smart contract from the Raspberry Pi command prompt. And thanks very much.